this app visualize how covariance is calculated. What you see here, it's a population. All these gray points are part of the population. And then you can see that every point is represented by two variables, x and y. Okay. You can also see that there is a linear trend between these 2 points, which can be made either stronger if you reduce the noise. For example, you can see it's like more linear, or you can make it a little bit more scattered around this imaginary line. Slope, you can also change the slope of this line, but let's keep this as we have now. Now, the idea of covariance is following. We simply find out how every point is far from the average along x and average along y, right? So what you see here, it's two lines, dashed lines. This line, the vertical line, it's average of x, 99.3 in this case, and the horizontal line, it's the average of y, which is 98.3. Okay. And then, for example, we can select a point. You can click on any point and select it. And then you can see that we measure two distances. How far x-coordinate of this point is from the average, this distance, it's shown here. So these are coordinates, x and y. And this is the distance, x minus m. And also how far y-coordinate of this point is from the corresponding average. It's this distance. And then we simply multiply these two distances, and then you can see that this distance is positive, this distance is positive, and therefore the product is also positive. So we can say that this point contributes to covariance positively. You can also select this point, and then you can see that in this case, both x and y coordinates are below average. So both distances are negative. However, because if we multiply two negative values, we get positive distance, you can see the contribution is also positive. Any points which align in this quadrant or in this quadrant, they contribute positively to the covariance, to the positive linear trend. The blue points, they have the negative contribution, and then you can see why. For example, if you select this point, you can see that the x-coordinate is below the average, the y-coordinate is above the average, so we have one negative distance and one positive distance, which gives you a negative distance as a product. But if you look at the blue points, you can see that the contribution of blue points is relatively small. The contribution is red points is much better, so it means that they are simply more far away, more distanced from this cross of two mean values. And therefore, if you sum up of all these products, you get a positive number. And if you divide this positive number to degrees of freedom, which is number of points minus 1 in our sample, you get the covariance. You can see this is the covariance of our sample. This is the covariance of the population, right? So you can see we have a slightly smaller number in this case. And then you can simply see that if you have a large amount of noise, every time you take a new covariance, you can see most of the time it's positive. However, it varies quite a lot, right? So here you have 1,000. And for example, here it's 800, here you have 300 and so on. So the covariance is positive, but variation is quite large, right? If you decrease the noise, if you make noise smaller, right? So this covariance value will be a little bit more consistent, although it varies also a lot. Of course, this is not covariance, this is sum of these values, and this is the covariance, right? But if you make noise larger, like this, so you can see that now the sum sometimes, I mean, most of the time in this case it's positive. Let me see if I can get a negative sum. Maybe I need to, I got a negative once. Yeah, this one. You can see now it's negative. So in this case, although we have a kind of trend, the trend is very weak, and therefore the covariance can be accidentally become negative in this case, right? So that's one thing. The second thing is that if you reduce the noise, if you make it, again, a very strong positive covariance in this case, right? So you can see all points are red in this case, right? Now, if I change the slope of this line, right? So if I make a slope like this, you can see now, if I take a new sample, now you can see all points are blue, right? So why all points are blue? Because we have a clearly linear trend with a negative slope of this line. So most of the points have this negative contribution because one of the distances is negative because they lie in these two. So covariance simply tells you about how x and y values co-vary, right? So if x is growing, what happens to y? Will it growing as well? Will it falling? Or maybe it will just not depend on the changes in x, right? So it will be absolutely independent. So it means that the covariance will be 0.